Hey everybody, this is Larry. This is Miko for Q3 of the weekly contest 418. Construct 2D grid matching graph layout. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I'm getting my drawing things ready. So this one actually, what was I do? It's actually not that bad conceptually. I think there are, I think this one's daunting to kind of look at initially, right? And the thing is that, given a lot of numbers, you know that there are a lot of possibilities, right? So if you try to start like, maybe my naive thought is that, okay, we start at the number 0 and then we look at all the edges. Maybe there's like, one, it's connected to 1, it's connected to 4, it's connected to a 5, but in which order, right? Even here, it could be 0, 1, 5, or, something like that, right? There are a lot of possibilities. So these are things that are a little bit tricky. So you definitely cannot go for that approach. And the way that I think about it is that there are a couple of edge cases, but the way that I think about it first is that I think there are people with a cleaner code, but during the contest, I don't care about clean code, honestly. I just want to get it done. And the way that I thought about it is that there are two cases, right? One is that it's basically 1D, one dimensional, 1 by X, right? 1 by one by R. And what I mean by that is that basically you just have a one-dimensional line, right? And what does that look like? Well, in that case, that means that you basically, if you count out all the edges, then you're just gonna have 1, 2, 2, 2, 2, 2, 1. And what I'm saying here is that one number or two numbers will have one edge, and then everything in between will have two edges. And here it should be pretty, I think if you haven't done this part yet, pause the video, solve for this particular case and see if you can do it. We'll go over the code later, but that's, I feel like most people should be able to get this, at least if they're attempting this and getting Q2, which as well, right? Okay. So then now the other case, of course, is sum R times C. And what does that look like if you draw out the number of edges? Well, it's just going to look like something like this. 2, the corner is always going to be 2, and then maybe you have 3, 3, 3, 2, right? 3, 4, 4, 4, 3, 3, 4, 4, and then something like that, right? And of course, the actual rows and columns depend on their input, but it can end like this, but it always has to look something like this, right? So that's the other thing. And then now, okay, but how can we do it? There's still a lot of possibilities when you don't think about it. Well, the first thing that I did, there are also a couple of things to realize, right? Is that without loss of generality, there are a lot of symmetric, I think 8 in total. You rotational symmetry, what was it called? Rotational equivalent class, and also the refractive one, right? But what all that means is that there are multiple solutions, but that's fine, right? And here, the easiest way for me, anyway, when I realized this, when I had this realization, is that we can just start at a 2, right? Because then now we know what one of the corners is. I actually, initially during the contest, I thought maybe I could start with the 4 corners and then branch out, but actually this is easier. Well, you have 2, then what does that mean, right? Well, that means that by definition, we know the 2 cells next to it. Why? Well, because it doesn't matter, right? Like, it only has 2 edges. It doesn't matter which one is which. You could even randomize it if you like, but then here, right? Then now, what does this mean? This means that, well, this is no edges left. This one already has 1 edge, so the current edge is 2. These colors are terrible, right? So this is a 2, right? And this is a 2 now, right? And then now, because this is a 2 and this is a 2, then we know that one cell can be determined, which is this one. Why? Because it has to be an overlap for this cell and an overlap for this cell. So then now we figure out whatever this cell is. And then now there are only 3 edges left, right? There's really no clean way to write this. At least without like, I don't know. That did not erase at all. At least not as efficiently as I would like. All right. Well, anyway, yeah. Now that we account for one edges, we know the number. It has 3 open unused edges left. Actually, sorry, it actually has 2 edges left, right? Oh, I lied about 3. It has 2 edges left because, well, we already know what 2 of the edges are already, right? And then now this, by figuring out what this is, then that means that this is 1 edge is left. This has 1 edge left, and because this is 1 edge and there's only 1 place to go, we also know what this number is, right? Then this goes to 0, this goes to 0, and this goes to, we process this. And then now, because we know what the edge this is now, then we set it to 2. We set this to 2, right? And in a similar iterative way, we know that there are only 2 cells, there are only 2 possibilities. For example, if you look at, say, this one, there are only 2 cells and there are only 2 possibilities, and one of them has to just overlap with this other cell. So that's basically what we do. We just kind of calculate the overlap. So then now there are 2 cells left, and then basically you just go do 1 diagonal at a time, and that is the idea. Now, honestly, I got this idea, I wouldn't say too quickly, but relatively okay. I also just if you look at my contest time, I actually did not spend an hour or 50 minutes here. What I saw more people got Q4, so I was trying to do Q4 and then I couldn't figure it out, so I skipped back here to do it. Maybe it was I don't know. I mean, I saw both, so I guess in the end it doesn't matter. But that's in case you're wondering. But yeah, so I got this idea relatively quickly, but without the details, and I had to work out the implementation. So if you want to watch me solve it live afterwards, definitely do that. You'll see me like try to figure out 1 step at a time. So it wasn't like I'm like, oh, you know, I got all of this. I just have like, oh, I think this idea will work, but I have to figure out how the pieces fit together given that idea, right? And that's really the thing. And here, I actually did separate them out. So here I count the number of edges, the count. I just have count. I don't know. The way that I did this is a little bit awkward, but nonetheless, right? And then now I go, okay, well, any node has with 1 edge. That means that we solved the 1D version. And the 1D version, it turns out, is just a regular, you know, you could do it with breadth first search or depth first search, but it's a linked list, right? It's a linked list. You just have to traverse it. It doesn't matter which order. It doesn't matter which, you know. As long as you traverse it in any order, any one order, this is fine. And this is how I do the 1D version. The 2D version is a little bit more involved, a lot more involved actually. I think I could have cleaned it a little bit better. I think we just basically, yeah. So I started off, I take any node of 2 edges, which is X. So this is going to be any node in the corner. So this is my starting node. I keep track of a done thing. And again, this is, I started off the corner by giving a 0, 0. And for implementation, instead of using a grid, I just put a lookup thing, right? So that, because I don't know the dimensions yet, so that's why I did it this way. So I started 0, 0, so that's the start. And then, yeah, and I mark it as done. And also I get the list of edges. I store this list as a set for lazy reason, but yeah. Yeah, and then here I just manually, I think I don't need to do this. I think I could have actually done this without making this, yeah, because I think my code actually would have handled this if I just, actually let's do that then. Let's give it a try. So previous is equal to start, and I don't think I need this anymore. Let's give it a spin. Nope, my answer is very wrong. Why is that? Huh. So this gets skipped. Oh, because this assumes everyone. Okay, fine. I think I could clean this up such that I don't need it, but in any case, fine. Yeah, I just added the corner, you know, as we mentioned, and then I added the two things next to the corner, also as I mentioned. During the contest, I'm fine with doing it this way and not optimizing it away, because, you know. And then here, it is kind of like, you know, basically, I think about it each one diagonal at a time, and this is the previous diagonal that we have, which contains the two numbers, right? And then one diagonal at a time. I call it a row, but this is the diagonal, right? And actually, I don't even use this. I thought I was going to use it, but though I think you could have just taken. Yeah. Anyway, so yeah, so I take the current update, right? So then now for in the new diagonal, I look at every two adjacent things in the last diagonal, and then I just try to figure out what's the common piece, right? So this is a very ugly way to get the common pieces, and then this is the dimension, and you just have to kind of figure, you know, you have to do the math on the visualization. I'm not going to go over in detail, but it's just, you know, like if you look at this, then, you know, like this is 0, 1, this is 1, 0. So then you do the math, and then their intersection is going to be 1, 1. So something like that. You could draw it out, and you'll see me do it live as well. But yeah, but that's the new XY, and then I just update the lookup to XY, and then I make sure that I had it done. And I set the current so that this is the current diagonal that we're putting one at a time from top to bottom, I suppose, or top right to bottom left. And then, yeah, and then after building all the common pieces, I go, okay, well, if we still have edges left over, meaning, you know, so what this part is saying is that if you bring up the visualization, which I guess I didn't go over, really. Basically, if you're here, actually, when you add this thing, you're done, right? So this becomes 0. But if it's not 0, then you want to expand this way. So that's basically what we have here in the code. And also for the downwards direction for this one. But yeah, so basically if the first item, which does not match with another item, then yeah, then we just kind of do the math on this way, and we expand to the right, or yeah, expand to the right, and this one expands down. And that's pretty much it. Yeah, and then at the end, we have everything in a lookup table, so I just get the maximum value of X and Y in that lookup table. And then I construct a grid, and I fill out the grid using the lookup table, and that's pretty much it. This is going to be linear time, linear space. Yeah, because at most each node will have 4 edges, right? So that means that the only linear number of edges. And so like all the set intersections or whatever only has like 4 by 4 objects, right? So yeah, overall, yeah, that's pretty much it. I'm going to show the code again. Here's the top. Well, here's the south 1D part here. And then the 2D part is, again, I start the corner. And then I fill out the stuff with the common pieces. And I fill out the top and the bottom. And that's pretty much it. Yeah, as I said, the idea I think is pretty okay, but it's just about writing the code in a way such that you can construct them together, and it took me a while, honestly, probably like 20 minutes just to make sure that I don't make silly mistakes as well. And yeah, that's all I have with this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest now. I'm sure about it. Can I do this one? Let's think about this one. Okay, so a number can only have up to 4 edges, right? But it can have 2 edges. If a number has 2 edges, it has to be in a corner. It has 1 edge. If any number has 1 edge, it has to be a 1 by D number, right? If any number has 2 edges, then we have 4 corners. And then we could build that out. Is that even true? Is there a symmetry thing? You don't know which corner though. But you take one of the 2s, the top, and then it doesn't matter by symmetry, gets the middle one, and then what? And then one of the existing ones have to go off that corner, right? Is that true? Because then now, yeah, okay, maybe that's fine. I don't know. Maybe if that's the case, 9 pure got it. I don't know if that's good or not. Yeah, whatever. Maybe this one is more doable, at least for a non-cheater. Okay, so conjugate, and then zero based, okay, and then now any edges or any edge, right? So for x, and if count x is equal to 1, then we just start from this one, right? And then now we have previous is this one, right? Yeah, just do it recursively, Larry. Trying to be too fancy. Something like that, except for I think I double counted start. Oh, right. Oh, it has to be a 2D, 1D array, so actually it is this. Okay. 0, 1, 3, 2, 4. Okay. And now okay, yeah. Basically we built on top. And by definition, this has to exist, so I don't think that there's another way. Okay, so then now it could be, we don't know the actual grid size, but that's fine. In this case, we would start. do it diagonally. Okay. So 0, 0, and then 1, 0, 1. We do it this. We start with a corner. The 2 doesn't matter, and then after that, we do this. And we should be good, right? Okay, so then now. What are you writing out? $50 minutes. You could get it, Larry. Come on. You could get one problem. That's row 1, so then now we're at row 2. I was debating adding a helper for this. Maybe we still could, because I already made a typo apparently. We don't know the size, that's why, right? So then now we go run previous as well. There's a lot of brackets. Okay. So 0, 1, 1. So we're actually going that way. I don't think we need done. Maybe we do, I don't know. I don't know which one we need, actually. So let's just do this for now. Okay, so then now we have this, and then we go. And now we have 4. Which gives us people are very good. Okay, so previous I minus 1. So this is the number. I think I want to set. So I could just do so then now the set intersection is going to be the common, right? So then now, okay. So this is the index. So that is the row that we are ending. This is the common. So then now it should be just all previous I. So that is the dimension. So 0, 1, 1, 1, 0, then it's actually no, it's going to be this. This is the new dimension. And that's the comment, right? So then, okay. Yeah, okay. And then done. I don't think we use done, but then now, yeah, we want to do okay, right? And now we have to get through the edges. So then now we do if this is equal to 2, then we're done. If this is equal to 3, then we have one more. So okay, so we actually have to do it before then, which is fine. Oh no, we have to do it afterwards because we don't know which one's left. Okay, so then now we also have to do some other stuff. This is a pending, but we also have to do the M of nope. Go to we want to be on the same thing, but with one extra on the Y. This is as well, but except for we want it in the other direction. See if this works a little bit. Set is not subscribable because I have E stored somewhere. I don't think I use M. So let's just get rid of it. This is actually yes. Maybe it loops infinitely. Yeah, okay. Let's just break real quick. Okay, so 0, 1, 2, that looks good. So then why are we not here? I'm going to solve this, but it is still very sad though. Oh, I am dumb. previous, current. Oh, this is wrong, isn't it? But they should have one more thing in common, right? I mean, they have. Actually, should return a set. Oh, this is not the set. I am dumb. Okay, and it should give me an error, I think. I was wondering why it wasn't giving me an error. 54. Yeah, does it print out correctly? Okay. So that's the common, and then now we have 4. Okay, this looks good on this part. This other part not so good, but I haven't worked yet. Well, this is no good. We do the same thing twice. Okay, so we have 07. So we have 1 07 548. as well. Is it? No, it's right. 107 548. Okay. 26 also right, and then 3. 6 and then 3. So 2 has. Oh, this is the count is not right. It is should be if count of things that are not. Maybe I could do something like that is a little awkward. Because we can also just remove, so from start it's fine. Let's just focus on getting it right first. So then now if length of if there's still 1 left, then you do this. Okay. Stop iteration. Why? I need to add X into it, maybe. Okay. Well, the indexes are wrong, but that's okay. 2, 1, 2. Oh no, it's just, I forget that this may not be, no, that's just 1. Right, so 4, 4 is 1, 3 should be 0, 0, 1, 1. 3 should be 2, 2. And that's the common piece, so it's this piece. Maybe I got it wrong. Nope, that's even more wrong. This is this. Okay. 1, 0, 0. Okay, and then now we have. Let's print this here out. Yeah. Is my a keyword? I actually don't remember. Would it complain? No, not yet. Will it bite me later? This index of error, do. Why does that only return it a 1D array? Because I am dumb. And x is the greatest number, so we need this plus 1. I am really bad at everything today. Okay, 0, 1, 2, 3, I guess that's fine. 105, 742, 863, is that in the right order? Looks okay-ish. Alright, let's YOLO submit. With only half an hour left, what else do I have got? If it times out though, I would be very sad, but yeah, how many people got this one? 63. Now we have to do the 250, the harder one. So this sucks on tiebreakers. But, yeah, okay. How do I even do this? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, this video, everything between the contest. And stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.